Thank you for the time today. My name is Brian Thompson. I'm the general manager of the Creo CAD business for PTC worldwide. I've been doing that job now for over 10 years. I'm in my 11th year leading the business. But I grew up as a mechanical engineer in industry before coming to PTC. I've been at PTC 16 years. So the last 10 of them managing the Creo CAD business worldwide. So we have some core AI capabilities in Creo today that have actually been in the product for many years in the form of generative AI optimization capabilities. So these use AI algorithms to optimize a design for meeting certain structural requirements as well as manufacturing requirements. So you could say have a design that has a certain modal frequency or has stresses below a certain value, but also maybe is a design that could be pulled from a mold, like a cast mold or an injection mold, or maybe a design that's intended to be manufactured. So those kinds of capabilities have been deeply integrated into Creo for quite some time, and we have excellent customers using those capabilities to optimize the mass of designs and optimize the functional capabilities of designs all over the world. But there are many other areas of Creo that look like they might be AI, but in fact are really good optimization capabilities. We were just talking here about a customer here in Japan that's using some optimization capabilities already built into Creo in our behavioral modeling extension to optimize certain load cases for the design of a seat. We have other capabilities in Creo that can help a design engineer document their designs with GD&T inside Creo and automatically know which surfaces of the design are not constrained, which surfaces of the design are constrained, and can even go so far as automatically grabbing all of the surfaces that are not constrained and keeping track of that as the user's design progresses. It looks like AI, but in fact, it's really just clever automation capabilities built into Creo. So we've worked very hard over many years to improve the productivity of design engineers, and these are just a few examples, some of which are AI, some of which are just really good design of helping the user be more productive. So the relationships amongst engineering data are very, very complex. There's been a lot of hype around applying AI in engineering, but when we look carefully at the way we thought engineers could most benefit from AI, we realized that trying to replace the management of the relationships in the engineering data with AI is a very difficult task. We don't believe AI is ready for that, but our systems have decades of experience in managing these relationships in very, very complex systems. So we believe a better approach is to allow AI to work within our systems to help the design engineer automate tasks that they have to do all the time. And there is plenty of opportunity to significantly improve design engineers' productivity by doing that while maintaining the intellectual property that customers have built into their data models by relating their different data elements in these complex ways. We're really good at that, and we believe that design engineers do the work to embed those capabilities or those relationships into their model for good reason. We don't want to risk that by applying AI to the design, but we do believe we can augment design engineers' workflows by applying AI on top of those relationships, which we will continue to maintain in our systems like in Creo and in Windchill. So this is why we've taken a very practical approach. We're not replacing those complex relationships with AI, but we are going to augment them. We think that's a better way to do that, and we'll see that this year as we continue to release new AI capabilities in Creo and in Windchill. PTC has set a framework for how we discuss the growth of our AI capabilities over time. Every PTC product will have a basic set of capabilities which we call advisory capabilities. Think of it as an AI agent built into the product that helps the design engineer understand the best practice for solving a particular problem in the product, or gives the design engineer immediate access to the help information about that product right there as they are working. The important thing to think about with these basic advisory service capabilities is that the advisory capabilities do not have direct knowledge of the data that is in session in Creo or in Windchill. They are simply providing quick access to help information about the system. But that's just the beginning. We expect everybody to have that this year in all of core PTC products, but the next step is much more exciting. In the next step, we're providing assistance to the design engineer. So this is much better because in this scenario, the AI assistant now has the ability to understand the data that the Creo design engineer has in their Creo session. The AI assistant can query information from that data, provide additional summaries and insights to the design engineer, and then under the direction of the design engineer, the AI assistant can even act and change that data. This is a significant opportunity for productivity gains because there are many things that can be done, say in a large assembly where the design engineer wants to make a similar type of change to many parts in an assembly all at once. Well, design engineer can do that one by one, or the design engineer can ask the AI assistant to make a very specific change across all of the parts in an assembly, and the AI assistant can do it very quickly. So we think this will be a significant advancement. This is what we call the assist level, the intermediate level, and many of PTC's products, including Creo, will also release capabilities like this year. But the future is even more exciting. The future level, the third tier, we call the automate tier. And in this situation, we now have the AI assistant helping to provide automation tasks to run optimization routines on behalf of the design engineer, maybe not just in the core system in which they are working, but maybe across multiple systems. We see the future of AI in PTC's products as coordinated activities across all of our products through agents that are talking to one another. Think about an agent in Codebeamer, our world-class requirements management system connected to Windchill, our world-class PLM system connected to Creo, world-class CAD system, and then connected to ServiceMax, world-class service-based management system. You can imagine the types of workflow automations you could create across the entire product development lifecycle with coordinated AI agent tasks. That's very much the future, but not that far out in the future because all of the core Creo products will have AI agents by the end of this year. So we're excited to see what maybe coordinated AI agent tasks could look like, say, in 2027 or 2028. I spend a lot of time with manufacturers here in Japan. I'm very fortunate. We have a very strong customer base. We're very proud to do a lot of business here in Japan. But the reality is we see many of our Japanese customers, they are making their 3D models and then from those 3D models making 2D drawings, which isn't necessarily a bad thing, but many of those customers are relying on the 2D drawing to convey important information about the design. This will be a problem with applying AI to those customers' data. What we want to try to make sure our Japanese customers understand is they need to think about modeling so that they could manufacture directly from the CAD model. They need to embed all of the manufacturing intent in the CAD model, because if they do that, then they will get the most value out of AI. AI has difficulty understanding the context of text that is put on a drawing. It is much better at understanding the context when the design intent is put directly on the 3D CAD model. And so our intent is to make sure AI is layered across the 3D data context and not the 2D data context. And so this is where I think the whole industry wants to go anyway. We see significant advances in model-based capabilities, both in our product and in model-based usage across the world. And I think in Japan, they've done such an excellent job with manufacturing efficiency. They haven't seen the need to move in that direction. But I think AI is an important factor in a decision for them to start to move into a more of a model-based world, because we're going to layer our AI technology on top of the 3D model-based architecture of Creo, not on the 2D. So I would like to see Japanese manufacturers move in more of a model-based direction. Even if they still want to make 2D drawings for manufacturing, they should still work as if they're going to manufacture directly from the 3D model. That will change their modeling techniques and will allow them to get the most value out of AI in the future. From the very beginning, even before Creo was Creo, when it was Pro Engineer, the product was developed with the CAD model at the center of the database. This was an important decision. Even when we added a 2D drawing environment to Pro Engineer, This is many, many, many years ago, even before my time at PTC. Even when we added a 2D drawing environment, the designers of ProEngineer made a very important decision. They made the 2D drawing environment a derivative of 3D. So when you look at a drawing in Creo, you are merely looking through a two-dimensional window into the 3D data. You cannot open a Creo drawing without having the CAD model. Okay, this is an important aspect. This is what I mean by Creo having a foundational model-based strength. Everything in Creo points back to the 3D CAD model. So over the years, as ProEngineer got stronger and ProEngineer evolved into Creo, we've added or improved many capabilities. We've added free-form surfacing. We improved our ability to do sheet metal designs. We've added semantic model-based definition capabilities. We've added world-class simulation through our partnership with ANSYS. But every time we add a new technology, we add it so that it points to the 3D data. We never add it so that it points to the 2D environment, because the 2D environment is always a window into the 3D data. This is important because whenever any database element in Creo is updated, those updates propagate associatively through the whole system, because everybody is always looking at the 3D data. And so, for instance, a change in a free-form surface might drive a change to a sheet metal part design, which might drive a change to a tool, which might trigger a change to a simulation that's done, which then might trigger a change to a manufacturing process. And the way Creo is built, that all those changes will all happen automatically, because we're always watching the part database, and any changes made to the part will automatically propagate everywhere. So why is this important in the world of AI? Why are we talking about semantic connectivity here? The reason is because these relationships in Creo are so complex. We believe that Creo needs to be a part of the story with integrating AI into design workflows. We don't believe AI is ready to understand those kind of relationships, but Creo is really excellent at understanding those kind of relationships. Therefore, when we add AI onto Creo, we'll add it onto this semantic connectivity foundation that Creo already provides by virtue of the way it's architected today, and this is going to unlock tremendous automation possibilities with AI and Creo working at this connectivity layer inside Creo. So this is why this is an important concept for our strategy going forward.